Hey, let's get ready for Unit 7, Lesson 7. We're moving through and looking at areas under a normal curve. Now, I just want to bring you back to the idea that we ended on with Lesson 6. You should have this drawn at the bottom of your Lesson 6 summary. This is a really important idea, our empirical rule. All right? So when we, and I didn't know actually even if we put the label here, so we call it the empirical rule. C-A-L. Sorry, empirical rule. That's because it was known across the empire. It happens everywhere in the world. That's why they call it that idea. So this division that we have going on here of 68, 95, and 99%. But you may be asking yourself, what happens if we're not locked in at these specific standard deviation segments? That's what we're going to look at today. So we're actually going to be able to find that percentage or the probability of any interval within our standard distribution, our normal curve. And we're going to see that we're not locked into just only those ideas. So we're going to use that normal distribution curve to estimate proportion of data falling within a given interval. Okay, so we're going to be using that. You will need some technology for this. So you will probably want to have the im.kendallhunt.com website available and ready for you. Okay, not here for our intro. We're going to just do it by hand here. So 7.1 starts us off with finding the areas under the curve. Both images show a normal curve with a mean at 40 and a standard deviation of 2. So we can see that the mean is right here in the middle. And then it's got a standard deviation of 2. That means it subtracts 2, then subtracts 2, then subtracts 2. And then it adds 2, the standard deviation adds 2, right, to find it each way. Okay. The area under the curve to the left of 39, so that's telling us this, everything from here this way is 0.3085. So about 31% of the values are 39 and lower. And the area under the curve to the left of 43, so 43 and lower, is going to cover about 93% of our data. That's how we're interpreting that. So it tells us these two values that we are given so far. Okay, so this is about 31% of data. I know that because of this 0.385. And everything from here this way is about 93% of all the data. Okay. So, since it is a normal curve, we know that the total area under the curve is 1. Use the given areas to find the areas in question. Explain your reasoning for each. So just giving us these couple ideas, we can start to calculate some other intervals. So a nice way to start. Find the area under the curve to the right of 39. The area under the curve to the right. So it told us everything to the left is 0.3085. And it wants to know to the right. So it wants to know everything, and I'm going to do this with my color coding. It wants to know everything from here to here. That's my question mark for number 1. All right. Well, if the whole thing is 1, and this shaded purple portion is 0.3085, the unshaded portion is going to be everything else. So 1 minus that shaded portion is going to help us out with that answer. So we need a 5 and a 1 and a, yep. I'm like you guys. I also want to make sure that I'm right. So I'm doing it on a calculator. Okay, so the area under the curve to the right of 0.39 or of 39 would be everything else that's left over. How about the area under the curve between 39 and 43? Now this is going to be kind of interesting. We're going to actually need to use some of these two ideas. Remember, these are the same curve with the same mean and standard deviation. Okay, they just have different parts shaded in. What it wants to know is the area between 39 and 43. Well, we just figured out that area 39 and more. Now we need to block it off between 39 and 43. So I would take this whole entire area, okay, which we know is 0.6915. And let's see, I want to eliminate this area and everything below it. Okay, so I want to cut it off at 43 and to start at 39. So here's what I'm going to do. I'm going to take this value here of this entire shaded area, and I'm going to subtract off the part that is 39 and lower. Okay, so I'm taking the full area from 0 to 43. That was 0.9332. And I'm going to subtract off this little part here because I don't want that part. I want everything in between these two. That part right here that I'm subtracting off is everything from 0 to 39. Okay, so we're thinking about this kind of stuff, subtracting off that range. 0.3085. Dear calculator. And I am finding that that is about, or it is exactly, oops, 0, we'll make that into a 6247. Okay, so about 62% of that data is within this range. How about the area under the curve to the left of 40? Well, that area under the curve to the left of 40, if 40 is right in the middle, and we want that area under the curve to the left of 40, all of it. It doesn't say anything about this shaded part or anything like this. I want everything from 40 up. Now remember what we're looking at. We're looking at all of that information. And our empirical rule tells us it cuts it exactly in half. Okay, that is exactly what that idea is. If I added 34 and 13.5 and 2 and 0.5, I would get 50% of the data here. So 0.5 would be that area under the curve. It is half of the full normal curve. Okay, and so finding the area of the curve between 39 and 40, well, what we're looking at is I want from the middle, and everything from here to there was 50% of the data, 0.5. And I want to subtract off that portion there so that all I have left is this portion in between from 39 to 40. Okay, so I'm going to take that 0.5. That would have been the entire lower half from 0 to 40, and I'm just going to subtract off this portion here, this 0.3085. And using again my calculator, tells me 0.1915. Okay. So we can use some basic information, even if they just give us two small pieces of information like this one did, and we can actually use that and calculate all kinds of other values in between and different ranges. So that's kind of cool. Coming up next, we are going to see how we're going to use technology to do this. Stay tuned.